After the lesson or at some point during the lesson. All right, here we go. So on the front page of your packet, it gives you some stuff, and this is why I say this gets kind of complex, because I mean, you think they've used variables and stuff before. Now they really get into some weird stuff with variables. Most of it isn't that complex once you see it with actual numbers, but the variables just make it confusing, in my opinion. And then they give you multiple, like all these function notation things, f of x, g of x, j of x. So it just is confusing. Maybe complex isn't even the right word, just confusing. So I'm just going to go through everything and just explain what it means for the most part. And then I'll tell you exactly what you need to know on the exit ticket I'm going to create. So typically, we're going to ignore that a to the x plus k thing for now. So on your graphs look a little different than that. I already put some dots in. You're going to do that in a second. But first, I want you to do this. You need to label. I'm going to use. So you see these three. These are functions. That's function of x. Function of x, a function of x. F of x is the middle line, middle graph line. The top, I mean, they're color coordinated if you can kind of tell already. So blue would be the top line, g of x. So you need to label these first. So that's the first thing you need to do. I'll just let you do that. I'll zoom. Yeah, I can zoom in on just the graph right now. We'll come back to the equations in a minute.
Well, hang on, X.
I'm not leaving it. I'm just zooming in on it. We'll come back to the equations in a minute. But right now, so since I'm zoomed in, now you can do the other part. The other part is to put the points on the graph. So for each line, you're going to put these points. Make sure you put them in the correct places. So you're going to need to look at the, the y-axis and the x-axis and figure out what the point is, and then.
So we will put another point right now?
Yep, go ahead and do it since I'm zoomed in. I was going to zoom in and have you do this, but I'm already zoomed in now. So you should have 9 points that you're going to put on the graph. And in a second, we're going to do something, and if you didn't put them in the right place, it won't work. So you'll know you didn't put them in the right place in a second. Anybody have any good weekend stories?
Oh, yes.
I know Aaron worked.
It ain't a story, but let's just say I had a lot of fun this weekend. I did.
All right, good. Looks like everybody's almost done.
Yeah.
Should have 9 points, correct. When you're done. 9 points written in. 3 of them will be right on the y-axis. 3 of them will be on -1 as the x value. And 3 of them will be on 4 as the x value. And then they'll just be where they intersect the lines. All right, so here's the next thing I want you to do. Pick any one of the 3 points. Actually, tell you what, we'll do it together. Somebody pick one for me. Say left, right, or middle.
Left.
Left is what I heard. So I'm going to pick, so f of x is like your original. This is the original line, or original equation line, whichever one you want to think of it as. In this case, we're only looking at the line, so I'll say it's the original line. And I'll explain in a little bit later how I'm going to quiz you. So what we're trying to find out, the end result, this is called transformations. Transforming transformations. We kind of did this before with linear equations. Transformations of an object. Could be a line, could be a triangle, could be a rectangle. It just means you're taking that object and you're moving it somewhere, somehow. You might also like spin it around or flip it. You might just slide it. But a transformation means you're taking an original figure, original object, and you're moving it. Well, we're taking this original line and we're moving it. Trick is figuring out how you moved it. And that tells you what kind of transformation it is. So, oh wait, we said left, is that what we said? So the way you want to do this is don't try to think of it as figuring out where the line itself is. You want to pick individual points and figure out where they went. So we picked this point. Where'd that point go? Far left point. You got it on your graph, so you can look at your graph too. Where'd that point go? The original point, the far left one on the red or the middle line for you guys. Where'd it go?
What happened?
Where did that original point, this original point go? Huh? That's actually right. I needed to give you a little more information. I just wanted to see what you'd say. Let's say we're only comparing the red line and the blue line. So you can really only compare two lines at a time. They happen to put 3 on one graph. So we're going to compare the red. Oh boy. All right. So you got one also. So now let's focus on just the red line and the blue line. So we're moving the red line to where the blue line is.
Okay, go now.
Now, yeah, hold on until I get to a break. Right now, or not right now, but on the red line, we have a point there. Where does that point go to get to the blue line? What did I do with that? Where did I move it to make the blue line, I guess I should say.
What happened?
What did I do with this blue point? This point on the red line, what did I do with that to get it to create, basically, I'm creating the blue line from the red line. How did I move it to create the blue line? Up, right? Clearly it's above, it moved up to get to the blue line.
Yes.
How far up?
Really high up.
Not really high up. Count. Well, it's more than 2.
4.
Not
3.
quite
No.
4.
No.
I'd say 3 is a pretty good number. 10, where are you getting these? God, do you not just,
Wait, you said
if I'm here, 1, 2, 3. All you do, you count.
No, I want back.
Count up. You just count it up. How far did I go up? 3. So, that's the first piece, but we're not done. We got to check the other points. Check that middle point. How far did I move that up?
Wait, which one?
The middle one, still on the red line. How far did I move that up? 3, right? So if I'm here, 1, 2, 3, and then I put it there. So if this was my original, these are all original points. Every one of those is really just an original point. It's just they're so close together, they look like a line. Remember, we've done that before.
Yeah.
All I'm doing is I'm taking each one of these, counting up 3, and putting a point right up there. So technically, I'm even doing that here. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. You're just moving every single point up through. And that creates the second line. Now let's look at the green line. So now we're looking from the red line to the green line. What are we doing to get the point that's on the far left? How do we get the point from the red line, the far left point? What do we do to that to start creating the green line? We just moved those all down 3, right?
So we move it everything
1,
down
2, 3. Well, count. 1, 2, 3. Here's another point. 1, 2, 3. Here's another one. 1, 2, 3. If we're doing those 3 down 3, then yeah, you're pretty safe to say we're doing every single point down 3. If it works with 2 or 3 points, it's going to work with all of them. Now I'm going to zoom out. Maybe. I can get it to work. There we go. Why do I always... That is so weird. Huh. Well, I always try to hit right under it, but it's actually way to the left of it. What happened in the blue formula or blue equation? What did we do to that original equation? Like look up in the section where it says numbers. What did we do in that? And what?
And we subtracted.
Think that's a coincidence?
We added and subtracted.
I think not.
We just added 3 to the equation and we subtracted 3 from the equation. All we did. All we did was say, I'm just going to take the original equation.
They went under.
Yeah. Oh, that's why.
We'll give it back.
No. Because this is exactly what I need it for all the time. So the original equation was this, right? So I took that original equation and then I just added 3 for every point on the line. That's what I'm doing. I'm just taking, because x could be an infinite number of values. That's why we shifted it up vertically, because this is just the answer. So every answer, we're just taking the answer and adding 3 to it, which looks like a shift up. Although it's kind of hard to tell that it's shifting up, because over here, it's hard to tell that these are shifting up 3. I mean, you could do it from here, like if we put a point there, 1, 2, 3, well, down 3 technically. So here's the first thing you need to write. On this page, if you are adding 3, that is a shift up 3. Shift down 3.
Oh.
Still a 3. We added 3, then we subtracted 3. Because we're taking the final answer that we came up with, that these are the final answers, and then we just added 3. So think about it, the y value just goes up by 3, because the y is kind of like our final answer. Because remember, we used to write equations like this, y equals 2 to the x. We used to have a y over there instead. So we're really just shifting the y value up 3. Again, if you don't understand all of that, this is the part you need to write down. You have that in your notes, you're going to be fine on the x table. I'll probably have one question that's like a little tougher where you have to have a little better understanding. But even without that, you'll still get a B if you just have these notes written down and what we're going to do over here. So now let's go to our graphing. Any questions on any of that? So far, it's pretty simple. Did you really have a question, or you just felt like talking?
He just wanted to say something.
Sometimes I like people do.
Why is it so original?
Well, because the f of x was just this piece. Then we took that piece and we added something on. Or we subtracted, so that's why that's the original, is because it was just the 0.5 raised to the x. So now, let's say we have a different situation. And now we don't have a graph. So now we just have the equation. I'm not making you graph anything on the exit ticket, but you need to know how to graph these types of equations. Oh wait, we're not doing that one yet. Go to number 5, not number 1. So number 5 is probably on the 3rd page, maybe?
Second.
Well, the 3rd page, including the cover page,
Oh,
right?
yeah.
All right, so I'm going to pretty much do these for you. Tell you what, actually, who was first person to the bathroom? You.
I asked before.
You went. So are you going to wait? All right, so if you want to go ahead and go now.
Thank you.
So when we graph exponential functions, remember we kind of just do these low numbers. So I'm just going to go from negative, and we do use negative, like you need to have a negative, unlike when we did linear equations, we didn't normally put a negative value for x.
Yes, sir.
So all a table means, just to refresh your memory, it's like a what if. we're saying, well, what if x is -2? What would my answer be? And again, for this equation up here, what if x was -1? What would my answer be? It's kind of like a what if thing. But here's the difference that we're going to do today. We're not actually going to graph this first, because this is going to be our second line that we graph. First, I want to know what would happen to just the exponential function part. What would that look like? So I'm just going to first graph 2 to the x power. I'm going to ignore the +1. So let's do it. I'm going to do these for you because the negatives are a little tricky because you got to do the whole flipping it into a fraction thing. If you put in, bless you, -2, you get 0.25. So you can write that down. If you put in -1, you get 0.5. You should be able to do the rest of them, but what's 2? Again, don't worry about why. We already did that. I'm not going to go back through the whole lesson of why it works, because you'll have calculators next year that you'll just, for the most part, do it on for this lesson. What is 2 raised to the 0 power?
What?
2 raised to the 0 power.
0.
Oh, well, most people said 1. Most people said 1. Anything raised to the 0 power is 1.
Okay.
Right? So now, what is 2 raised? So I'm just plugging in all these values, by the way. If you don't know where I'm getting this, I'm just saying, okay, well, what if x is 0? That's what this column means. What if x is 0? What would my answer be? This is the answer column. What would y be? Well, if x were 0, I'd have 2 to the 0 power. Well, 2 to the 0 power is 1, so I put 1 there. So what if x is 1? What would my answer be?
2.
Good, because I would say, okay, well, if x was 1, I'd have that. That equals 2. What if x is 2? What would my answer be?
4.
Good. And then if it was 3, it'd be 8. And you could also just remember the pattern thing should work. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. Multiply by the same number every time. That's the definition of an exponential function. So now I have my points. I'm going to go ahead and plot these. Oh, I should have written them smaller. I do this every time. Wait. My Zoom? Huh, I don't know. I'm just going to write it. I'm just going to leave it like this. Yeah, I should have written them smaller so I could fit on them. That's all right. I'll do it on the next one. So I always start over here for some reason 3, and then I come up to 8. And then 2, and then 4. You guys can just do this on your own. If you have them all on there, you can grab them yourself. 1 and then 2. Gets a little tougher to graph as they start getting really small numbers. 0, -1.5, and then 0.25 is definitely tricky. All right. So now try to draw your line in. Oh, that was pretty good. Oh, I ended it. I messed up. All right, so there we go. We got a blue line. I'll zoom in a little while. For now, I'm not worried about it. All right, so now we need to do this other column. You don't really have to do a whole column, but I'm going to go ahead and do it. So my equation now is the new equation, which is this equation. 2 raised to the x plus 1. So what am I really truly doing? Like, before I even just start plugging in x values and then solving out the whole equation, what am I just doing?
Adding 1 to everything.
I'm just adding 1 to everything I just got, right? Because we'd still, order of operations is do exponents first. So we would still solve this part first, and then we would just add 1 to it. So basically I'm just taking all of these values and then just adding 1 to it. So that's what I'm going to do. I'm not going to plug in any x's or anything. I'm just going to add 1 to all of the values I already have right here. So this would be 1.25 2, 5, 1.5, 1 plus 1 is 2, 2 plus 1 is 3, 4 plus 1 is 5, 8 plus 1 is 9. Now I can plot all of those. So, again, I'll start with 3, and 9 would be here. Huh. Boy, that's not a very good line. I gotta fix that line. I'm gonna go somewhere through that. So, I'm gonna do these in red. So 3 and 9 would be here. 2 and 5 would be there. 1 and 3 would be here. There. What would it be? -1 and 1.5. And then down there. All right, so now I'm going to draw this line. Man, it always messes up when they start getting really close together. Trying to do it right in. So, what did we say the transformation is if we're just adding 1 onto the end? What are we doing to the original graph? We're doing what? Just vertically moving the line up by 1. So we could check that, just make sure we did it right. Again, pick things where they fall right on. So here, 0 and 1. Well, yeah, I added 1. Here, 1 and 2. Yep, added 1. Here, 2 and 4. Yep, added 1. 3 and 8. Yep, added 1. Looks like my graph's pretty good. I could have just drawn the graph like that without ever doing this whole column. I could have just moved every point of 1. That would have been another way to do it. So, now here's what might happen too on a quiz. I may do this. I may not give you an equation. I may just give you the graph. Again, your first check is just, am I adding or subtracting the same number to get to the other graph? So am I adding 1 every time? Well, yes, I am. Okay, that means I added 1. Or let's say the red one was my original, then I'd be subtracting 1 every time. So that means I would have been subtracting 1 on the original. So that's your first check when you have those two lines. Am I adding the same number or subtracting the same number vertically? All right. Now let's come back to the other version. This one's a little tricky. Although with notes, it's really not any trickier, to tell you the truth. So we have this weird looking thing. A raised to the x. Oh, by the way, that's all this means over here. This funky, weird notation, it's just saying, well, if we have some original equation that's raised to the x power, and then we add some number onto it, like 1, it's just going to shift it up or down based on whatever we add. That's all this is saying. They just give you a bunch of variables in there instead of numbers. This part doesn't even matter. It's really just the shift that matters in this equation. This part just is going to change your original line. So, but it would still shift up or down whatever this number is, regardless of what that first part is. Again, this one's a little trickier. So do the same thing that we did, label the graphs. I'm going to get rid of this because it might be confusing. So here, so f of x here is the original. So it's the middle graph again. You guys have got to take notes. Again, you will fail the exit ticket if you don't take notes. There's no way you will figure this out on exit ticket. If you have notes, you'll get 100%. So you cannot fall asleep. You ready? Well, again, it will be a 100%. I'm just telling you, I will not help you on this. It will be a 100% if you have your notes. Well, maybe not 100. It'll be an A or a B if you have your notes. Probably be an F if you don't. You cannot afford to get an F on an easy exit ticket, because I've seen your other exit tickets. All right, so now let's just do a quick check. Let's just take some points that are, I'm going to do, that's why I need this. See? Let's take some points right now and just put them on this red line. You can do this part. A little trickier. I'm only going to put those 3 on because frankly there aren't a ton of good ones. Well, because this is 0, 1, -1, 2, -2, 4. Only ones I'm going to put on for now. I mean, I could do this one, I guess. So now let's do that same check vertically. How far up am I going to get to 8?
3.
So from here to there?
Oh. 10.
7. I'm saying 10, wait.
I just don't even know what goes through your head sometimes.
What you said, Mr. Gill?
I mean, I hope you're just throwing stuff out and just not even thinking about it, but if you're truly thinking about it and coming up with it, I'm just worried. From this point to this point, because this point is right on the 8. 1, 2, 3, 4, 5, 6, 7. 6 was closer than whatever he said.
Somebody said 7. I heard Frankie. Yep.
So now here's the thing though. Am I going up 7? I don't even see the next point for the green. So 1, 2, 3, 4, 5, 6, 7. I should be hitting green right there. I'm not. Right? So this is not a vertical shift. We're not just moving that original line up or down. That's because it's a different kind of formula. We're not just adding a number onto the end, right? We're actually adding or subtracting to the exponent itself. So this has a different type of transformation.
Oh, wow.
So if you'll notice, they used an example of 3, and they said, well, what if we added 3 to the exponent? Or what if we subtracted 3 from the exponent? So here's the shift. We're still going to use the same points we just put on there. Now what I want you to do, though, you guys put those points on there if you didn't. So 0, 1, 0, or -1, 2, -2, 4, and then -3 and 8. If you didn't already put those on there, put them on there real quick. You got them, Jasmine?
No, I was just curious.
Do you have those points on there? You need to have these 4 points on that red line. Got them? All right. Lauren, that's the last time I went Come on, bud. You gotta have notes for this. I mean, this is going to be an easy exit ticket if you have notes. It's going to be an impossible exit ticket if you don't. It is not something you can just figure out. I don't think. I mean, you could. Shouldn't be in this class. Should be in pre-calc.
Or science.
Like I said, where the stuff comes from, you say. Or science. So now what I want you to do with each of those points, or I'll pick one first. Count to the right.
3.
Count to the right from another one. Count to the right from another one.
4.
Were you okay?
So now we are shifting. It's still a shift of the middle line or the original line. Difference is we're shifting to the right 3. To the right 3. To the right 3. So that number 3 is still involved. It's just now notice though, this green line is this line here. It's so you need to write in this. That's the J of X line. So to the right actually means we're subtracting 3. So I guess I'll write that 0.5x and then we just subtract 3 from the exponent. This blue line is actually adding to the exponent. So that's the g of x equals 0.5 raised to the x plus 3. So there we're adding 3 to the exponent. So when you add, it actually shifts left. When you add directly to the exponent. When you subtract, it shifts it to the right. And we could check that by counting to the left. 1, 2, 3. 1, 2, 3.
What is that sign? That's
This,
yeah.
that's plus, x plus 3. Just like this one right here. I'm rewriting this right here. This 0.5x plus 3. So, I'm going to make sure you have all that down because I got to get rid of it in a second. Somebody waiting? Well, as soon as I write this, because you need to write this next thing down. So again, all of you need to make sure you have this next piece down. Just like we said, shift up 3, shift down 3. It doesn't matter what color I write in. I got to get rid of some of this, so hopefully you labeled this last line, the j of x, with the formula or equation for j of x. If not, you can just pull it from right there.
Oh, okay.
Oh, actually, I guess I could still at least leave j of x right there. Can't fix it out. So this green one is the j of x line. So now, if we go from an original exponential function and we add directly to the exponent, so all of that is an exponent, that shifts it left 3. If we subtract from the exponent, then it shifts it right 3. So you're going to have to tell me either from an equation, so I might just give you an original equation and then something like that or something like that. Or I might give you an original equation and something like that or something like that. You're going to have to tell me from the equation what was the shift and by how many. So you just count up or down or left or right until you find which one was the shift whenever it's the same number every time. So here it's left or right because it's 3 every time left and right. Here it's up or down, so it would be that kind of equation, one of those two, or one of these two adding directly to the exponent. Or I might give you the graph with no equation. And again, you'd have to tell me the same thing. Did I transform the original line by adding 3 to the end of the equation, by adding 3 to the exponent? Like, how did I transform? Something along those lines. And we're going to do a couple more, so you're not getting it, you will. All right, so now let's actually go back and do number 1. So when we do number 1, same exact thing we did before, x, y, -2, -1, 0, 1, 2, 3. So x is the value we're going to be plugging in. It's our what if. The equation is going to be, first we're just going to be doing 2x. Because we're then going to see, well, how does adding 1 to that x affect this last column? So we kind of already, did we already do that one? I don't remember if 5 was that same thing or not, but I think it was. So if we flip this, again, that's 0.25. Yeah, this is the same thing, 0.5. 2 raised to the 0 is 1. 2 raised to the 1 is 2. 4, 8. I'm going to just graph these real quick. So it's kind of the same graph you had on the other one, actually. 4, 8, 2,
That's why I don't like fractions.
1. Oh, that's messed up. What'd I do? Oh, I did do it.
The first one,
It's the same, the equation, the 2x is the same as we did before, so it'll look the exact same. It's when we add in the piece that is the part that we add to the exponent, it'll look different. Something like that. All right, so now we're going to do the other graph, and you'll see it's definitely different. So here we're doing y. Here we're doing y, but now we're doing y raised to the, so instead of 2x, it's 2 and then x plus 1 there. Not adding the 1 to the end result, to the answer, we're adding 1 to the actual exponent. So the first one would be if I add 1 to the exponent, and the exponent would be -2, well, that would give me an exponent of +1, right? So 2 raised to the -2 plus 1 is 2 raised to the -1. Well, again, I kind of already did that, right? 2 raised to the -1 was that answer right there. So I can just really, again, start to use my values. That would be 0.5. Well, now if I put in a -1, that's just going to cancel out and give me 0. Well, 2 to the 0 is 1. Well, you'll notice these are just going to repeat. So I'm going to write every single value down. It's just been kind of moved up one row. 3 would now actually be 16. So if I graph that line, again, I'm just going to graph some of the larger numbers because they're easier to graph. So 3 and 16 be up here. 2 and 8 be right there. 1 and 4 right there. And right there. Right there. Oh, it's hard to do it once you get down here, but. Now these lines look like they touch down here, but they don't ever touch. Because you're taking an original equation and you're doing something to it. So it's got to change the end value. But as you can see, if this was our original equation, just the 2x, and then we're adding 1, we'd be going from the blue to the red. So we're going left every single time, shifting 1 left, which is what we just wrote down. If we're adding 1, we wrote down before that that's a shift left. And then, of course, 1 unit. So just graphing it out proves to us. So you will probably have a graph or two where you have to tell me what the shift was. You'll have an equation or two where you have to tell me what the shift is. And then you'll have one where I'll make you think about it a little bit more, where it's not just a matter of looking at your notes and telling me which way it's shifted. So here's what you have to do on this. So 1 through 9. 9's a little tricky, but 1 through 9. Your butt out here. You smack that back in on them. You're going to go through and you're just going to tell me what is the effect if this was our original equation for all of them, like just the term that's being raised to the x is the original equation of every problem. So here, 2 to the x we'd consider the original. Down here, 4 to the x would be the original. 2 to the x would be the original. You're just going to tell me what is the effect of adding or subtracting or whatever the number is that they're adding or subtracting. What is the effect of that? Is it shifted up, shifted left, shifted right, shifted down? And then, tell me how many units it would shift down, which is just whatever the number.
I got a question. Are you doing fractions?
Yeah, the fraction doesn't come into play. So, for example, let's do number 2 together. This doesn't matter. This, again, the 1/3 doesn't matter at all. I'm not making you graph it. You're just telling me if this is the original function, what is the effect of adding a +2 to the exponent? What's the effect? You have it written in your notes.
2.
Well, actually, just not even in your notes. This one page is all you need to look at. If you wrote it down, so I told you to write down, right?
2, right? 2.
Well, it's adding to the exponent. What happens when we add to the exponent? Which direction does it go?
You
Goes
shift it
south.
up.
Shift up, shift down, shift left.
What are you
Goes
talking
up.
about, Mr. Gill?
Up is when we add it to the end of the equation. That's up. We're not
Oh, we
adding to
looking
the
at
end of the equation. We're
horizontal?
adding just to the exponent.
So it's left.
It is a shift left, exactly. So this adding to the exponent itself means it's a shift left, and then the units that we shifted is just the 2. That's just what we're adding.
How do you know it's-
That's what you have, because you should have written it in your notes. That's all you have to do for all of these. You don't have to graph anything. You just look at the equation, see what you're adding on. So the +2 here, the +1 there, and we're adding those to the exponents. Here, we're adding to the exponent. There, well, we're subtracting, I should say, from the exponent. Here, we're subtracting from the exponent. So you need to tell me what does that shift, what does that subtract 1 and that subtract 1, how does that change the original graph? So you just look at your notes where you should have written by each one of those example equations where I think they added 3 and subtracted 3 to the exponents. So you just need to tell me what shift would that make? And you just do that for every single column. We already did 5, sort of. So I'll come down in 5 and show you 5 if you're confused. Oh, is that 5? Nope. So here's 5. Now in 5, we're adding 1 to the whole answer. Like this would be the answer, 2 to the x. We're then adding 1 on top of that. Well, that means we shift it up. When we add 1 to the whole original function, that's a shift up of 1. So we're not adding just to the exponent, we're adding to the end of it. I mean, all you gotta do is compare it really with your sheet, like look at your sheet. Which one does this match up with, adding 1? Well, it matches up with the one over here where we just added 3 onto the end. Which one does this one match up with? Well, again, we're just adding onto the end, so it matches up with the one where we added 3 onto the end. These, though, we're subtracting 1 from the exponent itself. Well, which one are we adding or subtracting to the exponent? Well, that's the one on the right. And you should have written next to those what that does. So go ahead, go through, finish that. That's really all we're doing. I don't know why we're so early.
So, Mr. Gill, I can leave now?
Leave? What do you mean leave?
Your pass. My pass.
Did you finish this?
You didn't finish. Did it
I
with
just-
you?
I just told you to do the rest of them.
Oh.
Tell me which way they're shifting.
Okay, what number is it?
All of them.
Just tell them what you should.
Some of them have 2 shifts. No graphing. Not graphing anything. Oh, bathroom. Yeah, you can go down.
Okay.
Some of them have 2 shifts.
So we're just.
The first shift is always the exponent. That's always the first shift if it's an exponent. So I think 9, 10, 11, 12, however many are in the end. They have 2 shifts. So you would start with what happened to the exponent first. That's the first shift. Then the next shift is what happens to the whatever's added onto the end.
I don't get it.
Why am I not surprised? Try to do some of them on your own, and then I'll walk around and help. Again, if you have the notes, I mean, you're literally just looking at the example in the first, not even your notes, like the first page. I told you what to write down next to each one of those equations.
So we're not doing what we did, you know?
You don't have to graph anything. You are just telling me it would shit like this. So you're just looking at this one piece for each of them, whatever you're adding or subtracting, and saying that would shift it up, down, left, right, and then how many was shifted. What's that?
I'm just late.
I mean, you literally, I just told you what you would write, right? Exactly what I wrote. Shift left 1. That's your answer. for number 1. I did it for you. Shift left 2, did number 2 for you. That's all you gotta write. You don't have to graph anything.
Alright, so I'm about
I don't
done.
know why it's so
I got one
confusing.
more. So can you check this?
And then when they have 2, some of them, if you'll notice, if you get to the end, oh, I don't have any of those on here. I don't have 9, but if you look at 9, 10, 11, 12, and however many they have after that, there are 2 shifts. So first you look at the exponent shift, like what did they do to the exponent? They add something, subtract something. That's the first shift. Then the second shift is what just gets added on to the end of the whole equation. And clearly, I'm sure you know how many shift. Sometimes it isn't the same number. When you get into stuff next year, it may say 1 there, but actually shift 1. But not.
Oh.
Oh.
Oh, I finished. Oh. Oh. Probably. I did not do that.
Oh. I guess that's somebody, another teacher. Oh, who else was supposed to go somewhere? If you want to go, oh, let me just, you can just leave this here. Oh, yeah, this. So you can go ahead and go. And I'll just.
What I'm here, when y'all almost done, I got one more page.
Oh.
We're going to the same page. Oh, damn, never mind, I got a whole nother page left.
So left.
I need all.
Right.
No.
Like,
What?
I don't know.
Down.
Excuse me, I need help.
Yep, hold on. I'm looking at someone right now.
Sure.
I really hope you got the notes right now. I'm really upset if you don't. If you don't have the notes, no wonder you can't do it. I specifically said if you don't have the notes, you will not be able to do this. I really hope you got some of this stuff written down. I mean, all you need is that and that. That's it. I mean, you need to understand what it means, but as far as having it written down, hope you got it. You didn't have it, did you?
Okay.
Didn't have it, did you? Mm-hmm. Yeah. Yeah, funny you, not so funny Mr. Gill. Alright, let's go. We're not gonna do phones just yet, so.
Oh, no.
Nah, I'm just, you reminded me to say something on phone.
I don't.
Like that person right there.
No,
Put it up. No, you don't need phone. No. Yeah, but I'm not, no, but. What are you talking about?
I don't know my
Put it up. There's never a time when you need a phone. I've said that a million times.
Here. You can check that. I'm done for the day.
So I'll be. Alright, so, what's it saying there? Boy, you're better than me.
Yeah. Okay.
Handwriting.
I'm not, no wonder you
So what, explain to me what that means, like relative to what on that page?
Oh, that means go up, or down. What I need to know is where do I get the number? Right.
You don't need to do anything. Don't need to do a table, don't need to graph it. Go back to the word page. Try it again. What is that, where'd you get that shift up three? Where'd that come from?
This. From
So
this.
where did it come from specifically?
This.
Nope, not from the graph at all. Don't need the graph at all to do what we're doing. So ignore the graph. So it says shift up three. Where do you think that came from?
Here.
What about it?
You see, I gotta go now.
Oh, I didn't look. I'll look at it. You can go. That's fine. I mean, you're leaving your backpack. Yeah, you got 25 minutes. We'll be back.
You thought me what's a class?
Yeah,
I'll do that.
you definitely be back. They only got to talk to you for like 2 minutes.
You took this right. This right.
Let me work with this guy real quick and get him where he can do something. When you're on the right track, but specifically, what's part of that? It literally says shift up three. So
Yeah.
what part of that equation is telling you the
Oh, plus.
There you go. So, if you see so this was the original equation, right? Something with just a number raised to an x power. If you then add 3 to that, just like they took that original and added 3 to it, it's shifting it up 2.
Yeah.
Again, the key is I'm adding to the whole equation. Like I'm taking this entire thing and adding the 3.
Yeah.
I'm not doing what they did over here. Here they took the x value, the exponent, and just added 3 to the exponent itself. So this is very different than what they're doing here. Like you see how here they're just adding the 3 straight to the exponent x. Here they're actually adding the 3 to the whole entire equation.
Oh, okay, so this one's smaller. Oh, I didn't see that before.
Yes, that whole thing is the exponent. Here, that's the exponent, and then you're just adding this on the end. Same thing here. That's the exponent. You're subtracting it.
Alright.
So if you're just subtracting something at the end to the whole problem, that shifts it down. Here, if you're adding, go ahead.
So since this smaller is, this number is smaller, it means it's left and right.
Well, because it's an exponent. This is adding to the exponent. That's why it's small. Because that's telling you this 3 is being added to that exponent.
Oh,
Here, this 3 is not being added to the x. You're solving out whatever this might be. Then you're adding the 3 onto that. So you're using the 0.5 with the x first. Then you're adding the 3. Over here, you're actually using the 3 and the x first. Then you're using the 0.5. So it's changing the order you're doing.
can you check these?
I'm gonna stop the recording. You guys, I want you to turn this in. There's an assignment in focus. You're doing the whole packet. Just telling me, just like I was saying, what is the shift? So again, if you see a +1, it means it's shifting up 1. If the +3 or the +1 or the whatever is in the exponent, it means it's shifting it left or right. And you just use what I've written here to do that. So I'm going to stop the recording because we don't really need to record anymore.
Yes, but you don't have
So
to.
Kylie, just upload that into
I know.
Focus when you're done with it. It's due by the end of the day. It shouldn't take you long.
So this
Most
right
people
here,
took like 5 minutes.
That means
left, right.
Alright, that's, I get it.